Welcome everybody. Thank you for attending our session where we are going to try to rewrite Twitter in an hour. This is the agenda. So we will do a little introduction on what the session will be or will not be. A little disclaimer for you in the case you pick the session for the wrong reason, so you exactly know what you have to attend. We'll do a demo of Chattybirds. Chattybirds is the Twitter clone we wrote. We just go quickly on it to demo what it can do and where it is. Then Steve is going to talk about REST and WCF web APIs. I'll talk a tiny bit about Silverlight 5. Then Steve again on NoSQL and Redis, and we'll have a Q&A session. So the point of Chattybirds is that we were kind of tired about the very often used Northwind and Adventure works. Most of the time we do the same kind of application where we want to learn a new technology, which is we have some customers, they order some products, and it really doesn't help that much to learn a new platform. So we wanted to do some learning by doing, and to do that we have 3 steps that we identified. So what we like to do is we pick up a well-known website, Twitter, or a well-known application. Then you pick up a bunch of techno you're interested in, and then rewrite. The point is not to rewrite the entire application, because it would take us month and month, and I guess you don't expect us to work an entire month for the session. Something else, what the session is not, just to make sure you're attending the right thing. So we're not going to do a deep dive or full theory on Silverlight 5, REST, Redis, or anything NoSQL thingy. We're not going to show you how to use those technologies or anything. So what are those guys doing in front of you? What we will do is do a feedback session on the learning experiment we had on the usage of those technologies, what we learn and we think is valuable for you and valuable to share. So we will have some code highlights, like little pieces that we think are really, really nice or really useful for everybody. Some quick overviews, like how it works. I guess on Redis, Steve has some cool things to show. Some architecture and design that we want to share with you. So, as a disclaimer, so this is the abstract of the session. I guess you guys have read that thing before. One thing we would have liked to say, and it's really important, is that really buzzword skills. If you ever want to do a session, scope. Scope as much as you can, do as little as you can, because here we chose to do a lot, and we figured out a bit later on that it was very, very difficult to be able to talk decently on everything and do real deep dives. That's why we are going to limit ourselves on overviews and really small code highlights. But yeah, I mean, it almost killed Steve because of lack of sleep. So I'm happy to have him here with me today. So something else on the technology choice. So we chose WCF Web API, Silverlight 5, NoSQL, Key Value Store for Redis and REST. The point is not at all to say these are the technologies you have to use, or these are the best technologies ever, because they're not. There's no best technology ever. We didn't really want to make a point on choosing those technologies. The only thing that this means is we had to make a choice, and we did it. So I guess we could also have used HTML5 and JavaScript, maybe a SQL Server as well for the backend database. We could as well have built an iPad client consuming Ruby and MySQL on the backend, but then we would probably not be talking here today. So let's have a look at the application. And that's where the mirroring is handy. So let one small second. Okay, so that's just a tiny bit more convenient. Now it's going. Oh, crap. That's not how it's supposed to happen. Cool. And there it is. So, Steve, can you just play with it while I'm talking, because it's not. So, we haven't re-implemented the full login and security thing. We used what was provided by default with RIA services. We kept the forms and stuff, so login form is really not that complex. Just put a bit of style on it. So this is it. We haven't rewrote Twitter entirely, as I said. We just kept it on the basics. This was after he shut down the sound. So here it is. We have when you log in, you have your timeline with all the tweets from yourself and the guys you're following. You can go and check your friends just by clicking on the links. And so can you go on the other one?
Yeah.
Okay. So when you follow a guy, you can unfollow. And can you just click on unfollow? Thank you, Steve. So there you can follow. So the application adapts, hopefully, to the different states you can have. And that's pretty much it. And we will demonstrate, or try at least to you, that it was already quite a challenge with all of the technologies we chose.
Okay, so hello everybody. As you have seen, we have a few features that are exposed in our UI, but there's a lot going on in the backend. Maybe that's a bit too close to my mouth. Okay, so we have a lot going on in the backend. We have a bunch of technologies, so the WCF web APIs. We have REST services and Redis, the NoSQL key value store. I will also do a little poll. Has anybody played a bit with the web APIs? One person, okay, so it's a preview. And with a NoSQL database, like Redis? Nobody? Okay, so that's great. I hope I will be able to introduce you to that wonderful world. So the WCF web APIs, it's basically a bit too close. A new WCF stack for building REST services, and I will explain a bit what a REST service is. I will give you a quick overview of the theory so that you can understand what REST is trying to achieve. As I said, the WCF web APIs, well, this is a framework that is currently in preview 4 on Codeplex. So on one hand, I encourage you guys to go there, download the bits, and play a bit with them. It's still very early stage, but it's something very interesting that's going on there. And that framework is being pushed by a guy named Glenn Block. He's a PM on the WCF team, previously a PM on the MEF team. So I think that's very interesting what's happening in the WCF to simplify the network stack that was up to now quite complex. So a bit of REST theory. I hope I will not bore you too much, but I think REST is something very important in terms of design and architecture of distributed system. So if you are interested in that space, I recommend you to, well, learn about it. There is an awesome book called REST in Practice. I think it's a very important book. I would put it next to the domain-driven design book on my bookshelf. So really have a look at it. So what is REST all about? REST is about viewing the web as a platform for building distributed system and not just for entertainment in your browsers. It's about acknowledging that the web, the founding principle of the web, are useful for building complex distributed application in the enterprise world. REST is what we call an architectural style. So the term was first coined by Roy Fielding, who made a thesis on that topic. And what an architectural style is basically not something very strict and constraining, but it's more like a framework, a set of guiding principles that you can follow to have some benefits in your architecture. And the first three concepts that one start with to build a REST system are resources, identifiers, and representations. So resources are basically, well, that's a fundamental building block of the web. It's basically, I expose a set of information, of useful information, to the outside world, to the web, to the network, to the corporate world. And that's why we're talking about resource-oriented design, because the masterpiece is the resource. It's not something else like, I don't know, a message in SOAP or something. It's really, I can access some resource to gain something valuable from my system. I just said the word access. If we expose resources, we need a way to locate them and to identify them. So for that, we need identifiers. And the most pervasive thing that we have for identifiers on the web are URIs. So they just allow me to find a resource and consume it. The relation between a URI and a resource is, well, one resource can be exposed using multiple URIs for the simple fact that I can view the same piece of information. I can locate same piece of information with different names. But one URI will always point to one resource. Then, when I have accessed a resource, I need a way to process it, to transfer it. That's where the representation come in. And representation, if we think about the web, it's HTML, XML, JSON, JPEG. So it's not limited to data transfer format. It can be an image format, sound, and whatever format that hasn't been invented yet. So it's a very flexible and rich system. And so one resource can be consumed in different formats, different representation. And that's part of the content negotiation that will happen between the client and the server when the client asks for a resource. It will say, okay, I understand these type of formats, so please comply with that and send me something that I will be able to process. Again, we have a relation between the representation and the resource. So as I said, a resource can be exposed in different representation, different formats. And one URI can also expose multiple representations. So what we often see in REST APIs is that people add a .json or .xml at the end of the URI. That's not fully RESTful, actually. A real REST system should expose one URI without an extension, without extension, and this is the content negotiation that will determine which representation that will be used when the resource will be sent to the client. The fourth piece in the REST architectural style is the uniform interface. What is a uniform interface? Well, we have resource, we have identifiers, we have representation. Now we need a way of communicating, a protocol. And that protocol is, well, one of the most well-known protocol is HTTP. We could have some others, but HTTP is so ubiquitous on the web that it's basically the default choice. And why is it a uniform interface? Because we have a very small number of verbs with a well-accepted semantic. So all the routers, all the computers, all the servers understand HTTP. They understand the semantic of the verbs. They know that get is idempotent. What I mean by idempotent, you can request a resource multiple times, you will not trigger any side effect on the server. So basically, the client cannot be accounted for side effects that would happen on the server. And so I said we have a small number of verbs, so get, post, put, delete, and a few more. And they're well defined, well supported in the industry. And we also have a set of standard return codes, status codes, that the server will send along with the response. And basically what REST is stating is that with that uniform interface, that small number of verbs, the standard written code, this is enough to cover the majority of the needs of building an enterprise application. You don't need all the complexities of SOAP with all the WS Death Star extension. REST pretty much covers, in 99% of the case, what you need to build a fully distributed enterprise application. Then REST also defines what is the icing on the cake, the final piece to the realization that the web is an incredible platform for building enterprise application, and it's called hypermedia. We also hear the term ATOS. So hypermedia basically states that resources, when they are returned to the server in a certain representation, are not just pieces of dumb data. They also contain links, relations to either other resources or to that same resources, but to a different state of that resource, which implies that the clients can then use those links, those relations, to trigger some state change on the server, so some kind of workflow, or it can navigate to related resources. So we have kind of network of resources. And that's where the term REST comes from, which REST actually means representational state transfer. So it really means that the web is allows to build very, very stateful and meaningful distributed workflow based on these simple principles that I've just stated. We also see the term HTOS, which means hypermedia as the engine of application states. So basically, you can build your application in a loosely coupled fashion by following all those links and relations that you will receive from the servers. And what's very distinctive, what's very important, and what you have to understand is that when I say workflow, the actual workflow is dynamic. The states and the state transitions that we have on the resources that are exposed are not frozen. They are not known in advance. Maybe a few are known in advance, but they can change while the system is in operational mode. What I mean by that is that when you will request a resource to the server, you will receive some representation with links. Well, today, the resource is in state A. I will receive a bunch of links. Tomorrow, the resource will be in state B. There will be other links. And after tomorrow, I will be in state C, maybe at version 3.5 of the system, and there will be other links that will appear. So it means that I can build systems that can evolve over time with new features being added gradually. Try that with SOAP and messages with contracts. That's much more difficult. So that's the full realization of hypermedia and HTOS. Then there is also a term that you will probably encounter in the REST world. It's called the Richardson maturity model. I think that it sounds pretty cool. I would like that soon, that one day there was a maturity model named after me. Maybe. We'll see. Basically what that maturity model is stating is that it's basically ranking system based on their web friendliness. So how far do they go to leverage the different REST features and principle? It's actually modeled as a little pyramid. It states that the level 0 is for systems that use only one endpoint, one URI, and also pretty much one HTTP verb like get. And this is what you usually see with SOAP-based system. So pretty much most of the WCF services that we see in the enterprise today are level 0. Why? Because with one URI and only one verb, usually get, we really don't follow the semantics of HTTP, and we don't leverage all the features that HTTP provides. So we basically use HTTP as a transport protocol, while we could use it as an application protocol. Level 1 is that we use already a bit better structured URI and more than just one verb. Level 2 is we fully use multiple URIs, multiple verbs. Level 3, we even go further. We are actually also using, in a meaningful way, all the return code of HTTP. And also the caching features of HTTP, which are actually very powerful. HTTP contains very advanced distributed caching features that you can leverage in your application. You don't need to do caching server-side behind your services. You can leverage those features to build some very resilient, fault-tolerant system and very scalable. And level 4, as you can guess, is systems that leverage hypermedia. So they go to the full extent of what the web provides with resources containing links and relations. Okay, that was for the very boring theoretical part. We'll go to something a bit more practical now. So as I said already, HTTP contains a lot of features that allows the web to be very scalable and performant. So if you use the caching features that you put in the response headers, it allows proxies and intermediate servers to cache parts or response for some time. So it means you can decrease the number of requests that will actually reach your server, and that's what you want to do when you want to build a scalable system. It also allows your client application to be quite loosely coupled to your server, which is not really the case when you build SOAP-based system. And it's a very rich platform for building application. As I also explained, it allows very flexible evolution of APIs and data types and type of information that you return from your server. And I have the Richardson maturity model again. So, as I said, that's the theory. Now, from a more practical point of view, if you want to implement REST in your enterprise system, I would say don't try to shoot for the stars and directly, aim for hypermedia-based system. I think you have to do it. Take it step by step. First, learn how all the concept of building REST services. Go to the different steps of the maturity model, 1, 2, 3, and be practical, because that's a lot of theory, and some people are very religious about REST, but that's something we won't discuss here. I've identified a few steps to build REST services in a very pragmatic way. The first thing is that I think it's very good to build the REST services from the outside in, so that the design of these services will be guided by acceptance test, and we will see some code. So it means I will not start writing my REST services directly. I will first code a few tests that says, okay, if I send a request to that URI with these arguments in the query string or that information in the content of the request, I expect to receive that as a response. I expect to receive this status code in return. I expect to receive the information in that format, in JSON or blah, blah, blah. And then I can start writing the service. So what is also nice is that when you start writing those acceptance tests first, well, you can actually compile the test and run it, and it will fail. While, compared to more traditional unit testing, if you write the test first, well, you have to also already create the class, otherwise it's not going to compile. Here, the test will send an HTTP request to something that doesn't exist yet, so there will be no answer, that's it, but you can run the test. And you can go through the full cycle of TDD, which is red-green refactor. So I think that's a compelling argument to say that you should design your REST services from the outside in. Next, what I have identified is also how to model your resources in code and resource builders. That's, I don't know, a term I found. I'm not saying it's the best practice, but I found it nice and it made sense for me in the code. I also want to point out that you should separate the code in your REST services and resource builders from the models that you have behind and the repositories. So by models, it can be a domain model, it can be a data model, but there shouldn't be a one-to-one mapping between your model and the resource that you will expose to the outside world. There can be a one-to-one mapping, but it doesn't mean that it's always like that. And then also you should really use meaningful HTTP status code when you are returning a resource or when you are not returning a resource because, for example, the user is not authorized or the request that you receive is not correctly formed or does not contain correct data. So we will also see some examples of code. And actually, looking at my slides, we will look at the code right now. Okay. So let me start Visual Studio here. All right. There we go. Okay. Do you see something? All right, that's better. Okay. So let's close that guy. Go away, go away. So let's take a, yeah, by the way, so all the REST APIs that we have re-implemented here are, we just not invented them. Actually, Twitter on their website has a full description of their public API. So you can directly go see this page, and you have all the resources that are exposed, and they explain, if I take one, for example, the user resource, users show. So we have here the URI at which the user's resource is accessible. They add a version number in their URI to imply that there is some kind of API versioning. Then I have the user's resource, well, actually users/show resource. And they add a format. So it's not really RESTful in the pure sense of the term, but I guess, you know, you need to do compromises when you expose a service like that is used by millions of people. So here they add an extension that is either JSON or XML. They state clearly what is the method that is supported, the HTTP verb, and whether you need to be authenticated. Authentication is a tricky part of building REST system. They also explain which are the parameters that you can pass in the query string, and a sample of data that you will receive. Here it's XML, here is JSON. I think the font looks a bit crappy on the screen, but I guess you get the idea. So when I will build a REST service with the WCF web APIs, does that look okay on the screen? Pretty much, yeah. Well, first I define a class, so that's my user service. So this is re-implementing the REST API I've just shown in the browser. I define an attribute service contract, so that's still plain old WCF. I do some, fancy dependency injection. I think today, if you don't do a dependency injection, people don't take you seriously. So I thought, okay, let's do it. And then you define public methods that you will mark with attributes like web get or web invoke, and and a URI template. So basically, at which URI the resource will be reachable. So here I have show.json, and then the query string. So I have multiple optional arguments that I can pass on the query string, and in this case I have to put them all in there. I don't know if you can see skip status, and I will receive them as argument to the method. And what I return is an HTTP response message of a particular type of resource, or it can also be an untyped HTTP response message if you don't have a class to represent the resource. So what's very important to understand is that I've seen some code actually using the WCF web APIs that expose the service as the resource itself. And I think that's not totally correct, so I prefer to still use the term service for the code that is, the plumbing that's using WCF, and model resource as a separate abstract class that represent what is going to be returned. Then here I basically process the arguments. I verify that we have a valid type of information, a valid user ID, a valid screen name. If not, then I return a bad request. So how does that work? Bad request is basically, and again, that's something very specific that I've done, but I think it looks nice. It's a set of extension methods that basically mimic the HTTP status code. So I have bad request, I have created, I have not found, forbidden, unauthorized, invalid. And these are extension method on the basically a marker interface resource, which means that, it's a bit funny, I can return a bad request for the user resource. Actually, if you're looking at the code, when I'm here, the user resource variable is null, but I just laid out the code that way because it looks nice. And then when I have made some checks on the request that is coming in, I can delegate the work to a resource builder, passing in some arguments. Then the resource builder will build the resource, and then I return not found or success. And in the case of success, the resource will actually be sent to the WCF APIs that will convert it to the appropriate representation depending on the content type negotiation that has happened between the client and the server, using the content type supported by the client. I spoke a bit fast. That was a lot of information in one sentence. I hope you got it. Let's go check what resource builder is made of. So I have a iResource builder. That's still a marker interface. And what you will typically see is that the resource builder will be injected with repositories that allow you to fetch data, basically. So I have, again, very simple code. Either fetch the user by ID or by screen name. Trying not to throw exception here. If I can't find a user, just return null, and then we make a check in the service and return a not found. And then here I build a resource, and Twitter in that API also return as part of the user its current status. So I might have to call the status resource builder. And then I convert that. So convert what I've received. I'm actually receiving model classes, and I convert these model classes to a resource classes. And how it happens here? Well, it's very simple and stupid code. Just copy the properties. But as I said, the mapping will not be always one-to-one, and you will probably maybe not copy all the properties. So there's something like an aggregation that can happen in the resource builder. Also, the repository is something you might want to fake or mock in your unit test. Speaking about unit test, how are we doing in terms of time? I think it's okay. Okay, now to show you what a test looks like, let's take something like this. So I haven't used any particular fancy testing framework. It's just pure MS test. And I'm using some kind of fancy names following a bit the BDD style. I don't know if you've come to encounter that. So basically, I have when getting users show resource, and then I have my test methods that states something. It should use a JSON content type. It should return a user by ID. It should return a user by screen name. That one is ignored because it's failing, but yeah, it's going to be fixed. It should return the user current status if not skipped. It should return a 400 bad request, 404 not found, which has the nice property that when you run them, you can actually just read and understand what the purpose of the test are. Yes, here, yep, let's retry, let's restart. I'm automating Redis because I need Redis server. I need a Redis server while the tests are being executed. Start the Redis server. And something is going wrong. Guess that's the demo effect. But I assure you, it was all green. By the way, all the code that we have for this application will be posted on GitHub. So, as we said, it's a learning platform. If you want simply to look at the code to see how it's built, or maybe even to contribute some patches because you find it interesting, I mean, feel free to do so. We'll post the link to the GitHub account a bit later. Okay, so that's really for the backend part. Now we'll talk a bit about how REST integrates with Silverlight. And I have to tell you, it's not an easy thing. So let's go back here. All right. So we have seen that, as I recommended, start designing your REST services from the outside in, and then when you have something working, you will integrate that with your front end. So here we picked Silverlight. As we said, it's more like a choice we made because, well, we are developing Silverlight application in the enterprise. Meanwhile, since we announced the session, there was a big fuss about HTML5 versus Silverlight 5. So, you know, things change. So about Silverlight and REST services, the status is that it's not yet a perfect love story, so be aware of that. There are some important information on that topic that I have to communicate about that. It's basically that Silverlight has two browser stacks, two HTTP stacks. The default one is basically the browser one. So when Silverlight will make a request, an HTTP request, it will simply use the stack of the browser. And that stack is very limited. It only supports get, HTTP verb, and post. And that's pretty much it. On the other hand, it automatically handles redirections, cookies, and a lot of other things. But it's limited, and it's not the fastest one. There is another HTTP stack in Silverlight since, I think, Silverlight 3. That's a client HTTP stack, and that one is much faster, even faster in Silverlight 5. They're talking about 90% improvement on the latency. But you have to do a lot yourself, basically. So, yeah, things are a bit more difficult. You have to handle cookies yourself. Which means that for authentication, things are a bit tricky because you have, well, your Silverlight XAP is being authenticated in ASP.NET, but then ASP.NET sends back a cookie to along with the response of the authentication, and that cookie is stored in the browser, but not in the client HTTP stack, which means that if you're using the client HTTP stack for communication with your REST services, you are basically not authenticated. So either you, as I did, authenticate a second time with your REST services. That's a bit of a pain, but it works. Or, well, some other option that OAuth and more, well, basically more complex option. You can also use basic HTTP, which means that every time you call your REST service, you will transmit the username and the password in the request headers, which a lot of people consider unsecure unless you're using HTTPS, which you should do anyway. Things should be okay. So there are a number of different authentication options. Basically, we just took an easy one. We've used RIA services authentication service on the back end and override things a bit to return a cookie that the client HTTP stack can store. What you also have to do is grow a client API. Once you have something working on the back end, you grow some small classes, some small helper classes and models that your UI developer can use to start working in parallel. Okay, now I will let Georges talk a bit about Silverlight. I think I've been talking a bit too much about REST.
That's not a problem. So actually, this new version of Silverlight 5 is coming in September, October, or maybe not coming. I don't know. This one doesn't have a lot of very new, cool features besides basically those ones. So they made a lot of improvements in terms of performances and stuff, but more. So I'll go through those ones anyway. Just so you know, I'll keep it short because there's not a lot to say. So the first one is custom markup extensions. That's something they got by from WPF that was really missing. So the idea is that you can add some tags in the XML to resolve some data. So the well-known markup extension they had was binding, so that was already existing, but you could not create your own markup extension. So so that's how it looks, like a binding status. So that's, you have some parameters like the string format and stuff, and which means you kind of have endless possibilities. That's really, really, really nice to be able to handle those things and play with that. So you can right away add a little tag into the value of a text box or something, and it's going to run some code that is somewhere else to get the data and put it back in the UI. So you can do math operations, web service, calls, localization. So this is what we did in Chatterbird. We did some localization kind of thing. So before you had to create your resource dictionary, the resource where you have all the strings, you have to create a static version of a static instance of that guy somewhere in the application resources, and you always had to access it through a static resource. But here you can right away use the app strings and key equal. This is much smaller. Maybe I can show quickly. Almost there. It's going to be easy. Okay. So I can't find it back. Well, whatever. Let's just skip it. Doesn't really matter. But the idea is that it's going to help you to really shorten the code in the XAML, which is pretty awesome, I think. Okay. So basically, on the other general stuff, you have some XNA benefits from the Windows Phone 7. Some very cool 3D capabilities. I don't know if you have watched the mix even where they present the Silverlight 5. they built some really nice 3D applications. You have some trusted apps capabilities. So might sound a bit stupid, but before you could not access the keyboard when the application goes in full screen. They said it's a security reason. So you could not fake your bank website. But now you have the possibility to sign your application, and this would allow you to use to have a full keyboard capabilities into the browser. That meant that before that you could not have a game which used your keyboard and use the full screen, which is kind of stupid. As Steve said, they've made a lot of performance improvements on a HTTP stack, but also thanks to Windows Phone 7 again, they really worked on the UI performances and stuff. So also for the trusted apps, something I just saw I forgot. You have a broader file system access, so you can go much further than you were allowed to do before. Some things that are not yet in the beta, so I could not demonstrate them today. You will be able to do some vector printing, some power awareness, so that would allow you to reduce change the color from white to a darker color when the power of the machine goes low, so you can save the battery. Now there is no support for the 64-bit machine browser for the plugin, which means if you just cannot run an application in a 64-bit browser. And I don't know if you guys know the pivot viewer. So do you know the thing? So have you seen that? Yeah, no, yeah, whatever. So that's a new nice control that they made that is going to be made available. So actually, as I said, there is really not a lot to say about Silverlight. Maybe I should go back to the first Silverlight slide because I skipped some things. So on the data binding side, you now are able to do some debug. So most of the time when a binding fails, it just outputs something in the output window, and it doesn't tell you. There's no crash, no exceptions run or whatever, and you don't know that something happened and it is bad. And binding were quite difficult to troubleshoot. So now you can just put a breakpoint right away in the markup, in the SAML, and check what was wrong, what's the value that you get in the binding, and then you can way easily troubleshoot the issue and find the correct data to give to the object. There's a cool sound effect. I don't know if you've heard it. I'm not sure I should demonstrate that, but whatever.
Yeah. Demo effect.
I think it's going to break out.
Yeah, it's a crash.
Nope. Crash. Demo effect.
Okay, let's skip to Redis anyway. I think we don't have a lot of time left.
Yeah, 10 minutes left, so we should just move to Redis.
So, yeah, if Visual Studio wants to get out of the way. And I don't see the slide. Okay. So yeah, as basically as backend store for the data, we've used something a bit non-conventional. We could have used SQL Server or SQL CE4 or a SQL database, but well, we thought we're going to do a nice sample here. SQL is going to be a bit boring, and probably we will lose a lot of time as well using SQL. So we thought let's give Redis a try. So Redis is what we call a key value store. I'm going to show the website. Okay, so that's the website of Redis. It has a very good documentation. If I can find this one. Yeah. So you have a very extensive documentation. There is even a console, so you can try Redis online in the website. So basically, what Redis is, Go back to the slide. Just come back here. Okay, it's better. Come back here. It's a key value store. I don't know how many of you know about Memcache. Ever heard about that? So it's basically an in-memory database in which you store data at particular keys. Think about a dictionary in .NET, in C#. So it's basically a gigantic dictionary in memory, but it's more than that also. It allows, for example, to set some data at a key and to expire automatically that key with that data after a certain period of time. It also allows to, it has a lot of basic data structure, so more than just a dictionary. You can store, well, strings, integer, obviously, but you also have sets and sorted sets, and it contains a lot of low-level operation that you can do on those sets of data. You can like merge them, union them, and which, well, when you use Redis, you have to model your data a bit differently than what you usually do when you use SQL, where you model your data as tables, relations, you think about records. Here you really think about how can I store my data in sets of data. Will I use, for example, JSON to serialize them? How will I create indexes to have very fast access to some pieces of data? And we've actually used that for the timeline of Twitter. If you think about it, the timeline is actually something a bit complex. So you have two different types of timeline in Twitter. You have the user timeline, which shows all the tweets of that particular user, only those tweets, and maybe some of the retweets. And then you have the home timeline. So when you log in Twitter, you have your tweets. You have all the tweets of the people you follow. You have all the retweets that have been done by the people you follow. So you have quite a lot of information that you have to merge. And if you want to display that in a scalable way, well, you're not going to recompute the home timeline basically every time you access the website. So you have to do some kind of pre-processing in the background so that the home timeline is ready. Or you have to merge the different timelines of the user you're following very fast. And Redis is quite good at that. So basically, I will show you a little example after that. You will reach to the different user timelines and tell Redis, okay, merge them and give me all the tweets in descending orders and give me only like 20 tweets, for example. Think about what you should do to build a home timeline in SQL. You would have to go fetch the records for the different users and perform some very complex joins. And, well, basically, a relational database is going to be very slow for that, especially if you have writes that happen at the same time. And something people often forget with databases is that reads compete with writes in the same database. So databases are really optimized for OLTP, and here we are in a different world, basically. So as I said, it's blazingly fast. It's written in C, so it's probably one of the fastest NoSQL data store. The funny thing is that it's running the server is running on only one thread. Because it's so fast, it can process tens of thousands of requests per second with one thread. Try that with your WCF service. Yeah, and basically it's being mainly developed by a guy named, well, that's his tweet account, Antirez. Well, he has the sponsor of VMware, so it's not your little open source project that you do on site. It's something that's actually very well used in big projects. I think Blizzard is using Redis for World of Warcraft, or maybe their commercial website, something like that. So it's actually used a lot, but there's not a lot of advertising about it. It's a bit weird. I will quickly show you what it looks like. So basically, that's a command line interface. Oh my God, we're not used to that anymore. So basically, I can issue some basic commands to the server. So here, for example, all right, that's awesome. Let's go back to this guy. Yeah, that's simply because the server is not started. Okay.
Demo effect again.
Yeah. So let's list all the keys. That's the awesome keyboard of George. There you go. Can I get a star? Awesome. Okay. So here I have a bunch of keys. So they have a different kind of structure, as you can see. I have, for example, you are on something and then a number. That's to access a particular, let's say, record, if you view things as in the database world. I have, again, these are convention. I have an index to access the list of all the friends for one particular user. I have a home timeline, which is actually an index for a particular user. I have the list of followers. I have a fast lookup from screen name to user ID. And then what I can do, for example, I can query for the type of a particular key. So if I have, see what's the type of this one, that's a simple string. So basically, I can do run, and I have the JSON representation of a user. Then, as I said, you have a lot of different instructions to use for different types of data in Redis, and all the operations are usually very fast. The funny part also about Redis is, if I can get something meaningful here. Yeah. I don't know if you see it here. It's basically consuming 2 megabytes of RAM. I mean, compare that with SQL Server when you start it. Well, it's a bit different, let's say. What you can do with Redis, for example, the way people usually use it, they put that on a server, on a box, and they allocate something like 8 gigabytes to Redis, and then you can store massive amounts of data in there. It's using memory mapped files, so it can store more than just what you have allocated in RAM. And as I said, it can process an amazing number of requests in a very, very fast way. On the website, you can also see the complexity associated with each operation. We'll take back my server. So if you know the big O notation, you will have information about the expected complexity of each operation, and you should take that into account.